Today, I would like to explore the concept of a theory. Unlike its predecessor, this video will be using information from a previous video I made, What is Data? So please watch that video before you watch this one. It's only less than 4 minutes long. In my previous video, I thoroughly explained observations and data, but I glossed over the steps in between. It turns out that all those steps fall under the same term, a theory. In general terms, a theory is an algorithm which, when operated, outputs a data set for every observation set inputted. Now, an observation set is a set of certain characteristics for a single observation. Every single characteristic does not need to be specified. Only those pertinent to the theory are required. Now, a data set is a set of all the outputs of a single theory when a single observation set is inputted into that theory. Let me now give an example for each of these terms. When observing several videos of cars traveling down your road, you may wonder what each car's speed is. Each video you watch is a single observation, and the speed of those cars is the data. If we focus on a single observation, we can create its observation set using two qualities, distance and time. We then can use a theory, the velocity formula, to create the data set, which, in this case, has a single element. Using this theory on all the observation sets, we create data sets for all observations. These data sets help us to find similarities and differences between observations. Our next task is to create a theory of theories, the meta-theory. In a general sense, the meta-theory is a theory that judges the versatility of a theory. To understand what the versatility of a theory is and how the meta-theory will gauge it, let us revisit the purpose of data, which was explored in the previous video, as it is connected to the versatility of a theory. As it is, the purpose of data, that is, used to recognize the true relationships that exist within a set of observations, cannot provide any insight to whether one theory has higher versatility than another. This is because there is no way to confirm whether the relationships revealed by the outputted datasets are, in fact, the true relationships between observations, because confirming would also require a theory. Let us then modify the purpose of data slightly. The purpose of data then reads to recognize useful relationships that exist within a set of observations. This allows us to bypass the problems mentioned earlier, as we do not care about the true relationships, but instead the most useful ones. So we can rephrase the meta-theory, which now states that theories which reveal more useful relationships within a set of observations, or in other words, extract the correct data sets, have higher versatility. The terms useful and correct can only be specified when more context about the situation is known. For example, let's say I have a multiplication test of 9 problems. I want to find out how much more versatile the standard method of multiplication is than the 11 multiplication trick for this test. Correct data sets in this scenario can be defined as the data sets stated on an answer key. The standard method of multiplication, being able to extract these correct data sets for 9 times as many problems than the 11 multiplication trick, has 9 times the versatility of the 11 trick for this scenario, according to the meta-theory. However, for another test, the standard method of multiplication and the 11 multiplication trick could have equal versatility. This demonstrates how important the set of all observations, in this case the multiplication test, is for determining a theory's versatility. There are probably hundreds of other ways to define usefulness or correctness, some of which are stated here. The only important thing is that when the versatility of multiple theories is compared, they must be judged by the same standards. When each of these definitions is applied, certain patterns will emerge. For example, if the time it takes for data extraction is not being used to judge versatility, and theory A implies theory B, then theory A will, in every scenario, have a versatility equal to or greater than theory B. This was demonstrated in the earlier example because the standard method of multiplication implies the 11 multiplication trick. So with the meta-theory, we have an effective method for comparing any two theories with one another. By simply defining a set of observations over which they are to be applied, and by defining what usefulness or correctness means in terms of that set, it becomes rather easy to determine what theories are more versatile than another in that context. Thank you for watching.